Hi, 8th grade. Welcome to Topic 1, Lesson 3. We are going to talk about irrational numbers and square roots. If you did not already, please go grab your calculator from the back. You will need it for this lesson. Example 1. Darcy wants to add the ribbon shown along the diagonal of a rectangular flag she is designing. Does Darcy have enough ribbon? Explain. So looks here that Darcy's ribbon is 8.5 feet, and she wants to put it along the diagonal, so along this, where it says the square root of 74. So we need to figure out what the square root of 74 is in order to figure out if 8.5 feet is long enough to put along the diagonal. So it says approximate the square root of 74 using perfect squares. Remember, we talked about perfect squares. Perfect squares are squares that have roots that are integers. So 74 lies between two consecutive perfect squares, 64 and 81. 74 is between 64 and 81, and the square root of 64 is 8, and the square root of 81 is 9. That's because 8 times 8 is 64, and 9 times 9 is 81. So we know that the square root of 74 has to be between 64 and 81. We also can tell, if you look on a number line, that 74 is closer to 81 than it is to 64. So we know the square root of 74 is going to be closer to 9 than it is to 8. So find a better approximation by squaring decimals between 8 and 9 and then compare. So you can go through and do 8 times 8 equals 72.25. 8.6 times 8.6 is 73.96. Gets even closer. If you want, you can put the square root button in your calculator and find out what the square root of 74 really is. So if you put it in your calculator, you should have got the square root of 74 is equal to 8.6023 ... Goes on forever, does not have any repeating decimals. So what kind of number is this? Rational or irrational? Irrational. Which you should have gotten that hit because example 1 is all about approximating an irrational number. Let's try it. Between which two whole numbers is the square root of 12? So I want to look, what are the perfect squares? Remember, the perfect squares are 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49. We could go on and on. So 12 we're going to find between 9 and 16. So I'm going to put a 9 here and a 16 here. So that tells me that the square root of 12 has to be between the square root of 9 and the square root of 16. And we know the square root of 9 is what? What times what equals 9? 3. And the square root of 16, what times what equals 16? 4. So we know the square root of 12 is between 3 and 4. Convince me. Which of the two numbers is a better estimate for the square root of 12? Explain. Well, we need to figure out which number 12 is closer to. Is 12 closer to 9 or is 12 closer to 16? Well, between 9 and 12, there are 3 numbers. Between 12 and 16, there are 4 numbers. So that means the square root of 12 is closer to the square root of 9, which is 3. In our calculators, we can do the square root of 12 and find out that it is 3.4641. On and on. No repeating decimals. It is irrational. Next page, example number 2. Compare the square root of 32 and 5.51326. Plot each number at its approximate location on a number line. Step 1. Approximate the square root of 32 by using perfect squares. So they knew that 32 was between 25 and 36, and that the square root of 25 is 5, because 5 times 5 equals 25, and the square root of 36 is 6 times 6. Find a better approximation by using decimals, or we can do the square root of 32 on our calculators. The square root of 32 gives me 5.656854. On and on, irrational. So we do know it's between 5.6 and 5.7. Next, 5.51326 is a rational number by rounding to the nearest tenth. Nearest tenth. Tenth place is 1 after the decimal. So that would be 5.5. So 5.5 is less than the square root of 32. 5.5 is less than 5.65. Okay, so it's going to be lower on the number line. Example 3. Compare and order the numbers below. So what we're going to have to do is take each number and give it to us in a decimal form, rounded, so that we can put it on the number line. So the pi squared. Pi squared means 3.14 times 3.14, which gives us 9.8596. 9 1/2 as a fraction is just 9.5. Then we got 9.8, 9.5 repeating, and square root of 94 is 9.7. So the smallest number is going to be our 9 1/2, 9.5, which gets put right here. Then the next comes 9.5 repeating, goes right here. Then the next is 9.7, which is the square root of 94. Next is 9.8, and last pi squared. So to write them in order, 9 1/2 is less than 9.5 repeating, is less than the square root of 94, is less than 9.8, is less than pi squared. Try it. Compare and order the following numbers. The square root of 11, 2 1/4, negative 2.5, 3.6 repeating, and negative 3.97621. So let's put them all into decimal form first. If you're in class, pause it, and you can press play to check yourself after. But the square root of 11 is equal to, put it in my calculator, 3.31662479, on and on. 2 1/4. Well, I like to think of fourths as quarters. 1/4 is equal to 25 cents, so this is 2.25. Negative 2.5 is just negative 2.5. 3.6 repeating. And negative 3.97621. Okay, our smallest numbers are the biggest negative numbers. So the biggest negative number right now is this one, negative 3.972621. Then our next negative number is negative 2.5, so that's going to be our second smallest. Then we're going into positives. So the third number will be 2 1/4. Then the fourth number will be the square root of 11, since it's 3.3. And last but not least, number 5 will be 3.6 repeating. Hope you enjoyed the lesson. Get ready for the next one.